Okay, I wanted to share an example from 9.2 that is the t-test for comparing two population means. This is 9.2.5, the third one on the homework. Data on the weights in pounds of the contents of cans of diet soda versus the cans of regular soda is summarized on the table at right. Assume that two samples are independent, simple random samples selected from a normally distributed population or normally distributed populations, and do not assume that the population's standard deviations are equal. All right, so part A says test the claim that the contents of the cans of diet soda have weights with mean that is less than the mean weight for regular soda. And diet is mean 1 and regular is mean 2. So if diet has a lower mean than regular, this is a left-tailed test. So we're going to have that null and that alternative. Mean 1 is less than mean 2. All right, now we're going to use our hypothesis test calculator and plug these numbers in for our two samples. We're going to use the hypothesis test calculator, which is the two sample t for comparing mean. So here we go. Our first sample is our diet soda. The mean is, first sample mean is 0.79362 pounds, and the sample standard deviation for diet soda 0.00439. And the sample size is 35. Second sample mean for the regular soda, 0.81129. And standard deviation for the regular soda, 0.00753. And again, sample size is 35. Confidence level is going to be 95 because our alpha level is 0.05. Excuse me. Okay, and normally our null hypothesis will be 0 since the mean 1 is equal to the mean 2, and the null hypothesis, their difference is 0. So I think we have everything. Let's see if our test statistic works out. We have a very negative test statistic, negative 11.99. T-score. P-value for a left-tailed test is going to be 0. Very low p-value. All right, and since we have this p-value of 0 and a significance level of 0.05, we are definitely going to reject the null. Okay, we just tested the claim. Let's go back and find our claim. Test the claim that the contents of diet soda have weights with a mean less than the mean of regular soda. Well, if we reject our null, that means there is evidence for the claim. So we're going to reject our null. There is sufficient evidence to support the claim that cans of diet soda have the mean weight that is lower than the mean weight for regular soda. All right, now they want us to construct a confidence interval, but remember, this was a left-tailed test. Now, if we want a confidence interval to support our decision, our conclusion, we need to multiply our significance level times 2. So 0.05 times 2 is 0.1, and 1 minus 0.1 is 0.9. So we're going to have a 90% confidence interval. Okay, and when we put that 90% confidence level in, our confidence interval is negative 0.021 or 0.2 negative 0.020, and our upper confidence is negative 0.015. So both negative numbers. Does this confidence interval support our conclusion for the test? And I would say yes, it does, because we decided to support the claim that cans of diet soda have a mean weight less than cans of regular soda. And so subtracting the diet minus the regular would result in a negative number, and both of our limits are negative. So I would say yes, the confidence interval contains only negative values.